Hi everyone. In the previous video, we introduced the basics of hyperbolic functions, and in this video, we'll start looking at their derivatives and antiderivatives. Let's start with the derivative of sinh x. Remember that the entire purpose of hyperbolic functions is that they behave very similarly to trig functions. In fact, sometimes they behave exactly the same as trig functions. So just as the derivative of sine is cosine, it's also true that the derivative of sinh is cosh. So what about the derivative of cosh? Based on what we know about trig functions, you might guess that this is negative sinh, but actually it turns out it's positive sinh. When it comes to hyperbolic functions, definitely make a habit of leaning into your intuition about trig functions, but do so with awareness that sometimes there are slight differences like this. In similar spirit, the derivatives of these remaining functions look almost exactly how you'd expect them to. Just pause here and take a moment to write down all these on your formula sheets. And I find it helps to remember that the basic functions, sine, cos, and tan, are the ones that don't need negatives here, but that's only true for hyperbolic functions, not for trig functions. Although the derivative formulas I just gave you should feel pretty natural, how do we know they're true? Let's provide a proof starting with the derivative of sinh. So start out by declaring that this is the derivative that we want to find. And then in order to actually get this derivative, we'll use the definition of what sinh x is in the first place. Since the denominator here is constant, we can pull it in front of our derivative. And by doing that, we can avoid the quotient rule entirely and just take the derivative of our numerator. Pause and see if you can work out the remaining details, and if you're ready, let's continue. For the first term, we know the derivative of e to the x is just e to the x. And similarly, the derivative of e to the minus x is also e to the minus x times -1 according to the chain rule. Now the double negative can be simplified into a positive. And don't forget that all of this is still multiplied by 1/2. So what you see now should look very familiar because, after all, it's literally the definition of cosh of x according to the previous video. So this completes our proof. Next up was the derivative of cosh of x, but the proof of that is almost identical to what I just showed you, so I'll encourage you to pause and complete that proof for yourself. When you're ready, let's continue on to the derivative of tanh x. To prove this one, we can represent tanh as sinh over cosh. Notice at this stage we've already proven the derivatives of sinh and cosh, so all we need to do now is use the quotient rule. And the quotient rule says to take the derivative of the numerator and multiply it by the denominator, then subtract the numerator times the derivative of the denominator, and divide all of this by the denominator squared. All we need to do now is compute these remaining derivatives. We know the derivative of sinh x is cosh x, so in this first term where I see cosh x times cosh x, we might as well call that cosh squared x. Likewise, the derivative of cosh x is sinh x, so where we see sinh x times sinh x, let's call that sinh squared x. And don't forget, we still have this denominator to account for. Next, we notice the numerator here looks exactly like one of our hyperbolic identities from the previous video. So we know that cosh squared minus sinh squared is always equal to 1. And because of that, we can simplify our derivative as shown here. As a final step, we know 1 over cosh squared is just another name for sech squared, so you can write it as such, and that completes our proof. So far, we've proven 3 out of the 6 derivative formulas I gave us at the start of the video, but the proof of the remaining 3 is almost exactly the same as what I've already shown you, so I'm going to skip those details and encourage you to check them all for yourself. Now that we have a whole bunch of new derivative formulas, we also get a whole bunch of corresponding antiderivative formulas. So pause here and see if you can use what we've just learned to figure out what all of these integrals are equal to. And when you're ready, let's look at the answers. For starters, we know that cosh of u would be a function whose derivative is sinh of u, making it the antiderivative. So that gives us this first formula. Next, tanh of u is a function whose derivative is sech squared of u. Again, this should feel pretty natural considering what you already know about trig functions, but be careful. If you just pull on that intuition, you might think that sech of u is a function whose derivative is sech u tanh u. But actually, if you rewind the video, the derivative of sech contained a negative, so that negative still needs to be accounted for in our antiderivative as well. The rest of these are pretty similar, so pause and check that what I've just written down there is correct. And once you're convinced of that, make sure to write all these down on your formula sheet. And that's all for now, so I'll see you next time.